This is practice A for section 10.5. We're going to find the measure of each numbered angle or arc. Let's look at number 1. Number 1, we're going to use a new theorem. We're going to use theorem 10.11. Here's what it says. If a tangent and a chord intersect at a point on a circle, which is what we have here. We have a tangent and a chord intersecting at a point on the circle. Shh! The measure of each angle formed is half the measure of its intercepted arc. So notice how we have an intercepted arc right here. This angle, I'll make it green, is going to be half the measure of the pink arc. So if you guys don't have a calculator, please pick one up. 172 divided by 2 is going to give you 86. That's the measure of the green angle. Now notice how some of that angle is in the circle and some of the angle is outside the circle. That's okay. We're finding the measure of that angle formed by the chord and the tangent. So you're going to use that theorem for number 2 and number 3. Maybe we'll look at number 3. Looks like we're going backwards in this one. We want to know the measure of arc 1. We have the measure of that green inscribed angle. That arc is going to be 2 times 117. So give you 2/4. Now notice how we also have another angle and another arc. Same relationships go here. Notice how the orange angle and the green angle make a supplementary pair. Well, what is a supplement of 117? It'll be 63. And then double that would be 126. Now, when you're all done here, obviously your angles better add up to 180 and your arcs better add up to 360. Double check to make sure that's the case. That's how you use theorem 10.11. Let's use a new theorem. Let's use theorem 10.12. Notice how I can't use theorem 10.11 because I don't have any angles made by a tangent and a chord. I have angles made by 2 chords. Okay, so when that happens, we're going to use theorem 10.12. That's the angles inside the circle theorem. If 2 chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the intercepted arcs. Okay, so let's take a look at our 2 arcs. I'll make a yellow one and I'll make a pink one. You want to add those together and then you want to average them. Okay, so make sure you add before you divide. If you're doing this linearly in your calculator, you'd want to use parentheses around the addition statement. If you're using alpha x in your calculator, make sure the 131 plus the 33 is on top and the 2 is on bottom. And that's going to give me 82 degrees for the measure of angle 1. Notice how angle 2 is a linear pair with angle 1. So this guy over here would be 98 degrees. That's how theorem 10.12 works. See if there's anything else we could work on that might help us. Yeah, maybe number 8. Okay, so you're still going to use theorem 10.12. Maybe a little more complicated here. We got these 2 arcs that we can average and find the measure of that angle where that red dot is. Okay, now notice how we're missing 2 of those things, but we have some other things too. Let's see if I can complicate this a little bit more. Let's put a purple arc in. And let's go with some green. If I average my purple and my green, I'll end up with the 117. Okay, so that might be the approach that I'm going to take. Arc 1, I don't like the way that looks. Arc 1. I'm just going to call that guy X down there, if that's okay with you. X plus 132 over 2 has to be 117. Okay, now just solve that for X. Multiply your 117 by 2. And then subtract away 132. That's going to give you 102 for the measure of that purple arc. Okay, now we're going to do basically the same thing with the pink and the yellow arcs, but the first thing we got to do is we got to figure out the measure of that acute angle. We know it's 63. It's supplementary to the orange angle. Okay, let's do the same thing. I need to double 63 and then subtract away 86. And that's going to give me 40. Make sure everything jives. You can add up your 4 arcs. They better add up to 360. Okay, that's how theorem 10.12 works. Okay, now we also have one more theorem that we need to talk about. We need to talk about theorem 10.13. Let me read that one to you just to give you a refresher, in case you don't have your theorem packet in front of you. This works with angles outside of the circle. If a tangent and a secant, or 2 tangents, or 2 secants intersect outside of a circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. Hopefully that means something to you. Okay, if it doesn't, I'm going to explain it. We got these 2 arcs. Do you realize these 2 arcs are created by 2 secants? The secants create the arcs and the angle. You want the measure of that angle out there. We'll call it angle 1. It's going to equal half the difference of those 2 angles. And we're taking a difference because those angles are outside of the circle. Okay? Shh. So what's half of 48? It would be a 24-degree angle. That's how theorem 10.13 works. Okay, now maybe in some future examples you don't have those 2 numbers. Okay, that's why I started with this one, because it's a little bit easier. Okay, so obviously number 11 would work the same way. Number 10 might look a little bit different to you. You're still going to use theorem 10.13. But this time you have 2 tangents. Okay, so I'm going to come back here, and I'm going to say this was 2 secants. Okay, how would this work? Well, let's think about it. We have this major arc. It's 270. Shh! We have a minor arc that you should know the measure of. I know that arc measure is 90. 270 and 90 add up to 360. That's the whole way around the circle. Okay, now to find the measure of angle 2, remember what you do. You take half of the difference. 270 minus 90, I know is 180, and half of that is 90 again. So that angle 2 looked like a 90-degree angle, and we just showed that it is. Okay, let's try one more. Maybe I'll just pick number 13. We're going to use theorem 10.13 again. we have a tangent and a secant. We got this big yellow arc. We got this smaller pink arc. And then really what we're after is the measure of this even smaller purple arc. Take 360. You end up with 50. Subtract those two arcs away from 360. So 56 ends up being the measure of the purple arc. Okay, now once you have that, you operate your business as usual. Measure of angle 2 is going to be half of 134 minus 56. And again, you're subtracting because that angle is outside of the circle. 134 minus 56 divided by 2. I got 39 for the measure of angle 2.